Okay, so we're back and we have the layout that we just generated in the first video. Before we go over everything in the layout, I wanted to first do a quick review of what we went over last time. So when to use Eagle. Eagle is a tool that helps to aid in the development of printed circuit boards or PCBs. If you're not familiar with PCBs, you can look online and figure out what they are. Hopefully you do if you're watching this video. And what Eagle does is we can create custom parts depending on which integrated circuits you want to use on your circuit board and put them into a schematic. That schematic will then generate a layout, and that layout is what you were just looking at the start, and we can pick and place where we want our components to go on the actual circuit board in the layout. And then the layout gets sent through what are called Gerber files that we can generate in Eagle to a PCB manufacturer that we can do at very low costs. This is helpful because now you can really start cranking up your the number of circuit boards you get, and they look a lot cleaner than breadboards. When you're creating your own PCB in Eagle, we mentioned these steps of creating a new project and how to create a schematic last time. What I wanted to comment on here was these are some good recommended libraries to check out for some basic stuff. So RCL for resistors and caps, Con for connector, Supply 1 for ground and DC supplies, and Pinhead for your pinouts or your headers that you might want to use. Also, it's helpful to create a personal library, which we haven't gone over yet. I might go over that in a future video when we get into more complex designs. So for example, we went over how to add a resistor last time and pick the value using the 0603 packaging. So I wanted to draw out the difference between what the resistor looks like in all the different modes. So in schematic mode, it's simply a traditional resistor symbol that you may have seen in school or in textbooks. In layout, it's just two pieces of metal, two pads, and that represents where the resistor will sit. And on the actual board, it will be a very small rectangular prism component that you solder to those pads. So we also went over the different tools that we use in schematic mode. This is I want to leave this up for a second just as a nice reference for you if you forget what the tools are used for. And of course, you can just hover above each button and it will tell you. Feel free to send me any questions that you have about specific tools. And this is one of my favorite plots I've gotten from Wikipedia. I believe it was done by Zurich. And this just compares the size of surface mount components. So I mentioned last time not to confuse 0603 United States, which is shown here on the right, with 0603 metric or European, because you can see the pad size is dramatically different, about 1/4 the size. And if you make that error, you're not going to be able to connect your component that you want to connect there. One thing to note is you tend to move to larger sizes when you have higher amounts of current. Otherwise, you want to go as small as you can. So if you're a hobbyist like me who isn't great at soldering, I'm average, I always use 0603s because that's pretty much the smallest that I can handle. Some of my friends can do 0402s, but I do not recommend it, especially if you're starting out. You may even want to start with 0805s. And so we'll get back into the layout now. So what this video is really about. So first of all, an overview of the toolbar. So if I just pull up Eagle again here, you'll see I'm discussing some of the tools that are on the left side of this toolbar. And it's easier if I just show you the screenshot I did. So a lot of the buttons are the same as schematic, but some very important differences is this route trace button and the unroute trace button. So instead of using wires like we used in schematic, you will be using this route trace, and that is to help the layout and the schematic understand what has been connected and what needs to be connected. So if you look over here, you might see those yellow lines. So those tell you where the connections need to go. And once the trace has been routed, then those lines will go away. And unroute trace will just rip up any lines that you don't want there. Plane and polygon, these are useful for your ground planes or power planes. So traditionally we use these are 2-layer boards, so there's metal on top and there's also metal on bottom. And the metal on bottom is normally just a full ground plane, so we'll use the polygon or the plane tool to fill in metal everywhere on that layer. If you're familiar with power planes, you may also want to use a power plane using one of these tools. The via tool is critical. That's what lets you move layers. So if you're not familiar with this whole layer and via concept, there's many resources on the internet that can help you. The drill hole, this is used when you do not want a metal connection through the hole. So a drill hole is helpful if you want to actually have screw holes that attach mechanically to a structure external to the circuit board. So many times I put a drill hole in each corner of the board. Rat's nest, you'll be clicking this a lot. This is the tool that will redraw the yellow lines or the air wires to the closest nodes possible to make the connection. So this tool is very helpful. The electrical rule check is the same as the one in Schematic, but the design rule check is the one that ensures that your traces aren't too close together or too thin. So for example, many fabrication houses are limited by 6 to 8 mils of width and trace to trace separation. So you'll input that there, and this will go through and check to make sure you don't violate those. It also checks to see if you accidentally overlapped 2 different traces. This is a huge error, so you should be very thankful and make sure you use this DRC check because it will save you revisions and major errors. So let me go back to the Eagle layout, and we'll actually put some of these tools into our implementation. So the first thing to notice is your parts start outside of this white border, and this white border is what's called your boundary. So if I select properties, you'll see it uses the dimension layer. So the dimension layer is used by fabrication houses to know how large your board is going to be. If we look at the current layers being displayed, we have 1, which is red, that's for top, so that is your top copper. 16 is your bottom copper, that's blue. 17 and 18 are vias and pads. So pads are going to be exposed metal versus top copper is going to get covered with some kind of solder mask over it. Unrouted, that's the yellow. Those are your air wires that I discussed earlier that tell you can see down here where they're supposed to connect. Dimension, we just went over that. And the rest of these are more of superficial layers, as in they're not critical to the electrical structure of your board, but they do contain very helpful information. So for example, T names stands for top names and B names for bottom names. So if I turn off the top names layer, the R2 and R1 disappeared. If you weren't watching, I'll go ahead and re-add it, and you'll see them pop back up with the JPL or JP1 pins. So there's a bunch of other layers on here. I can go into these in detail in a different video, but these are, as for now, your most critical ones are your top and bottom, your pads and vias, dimension, and T names is very important because, and also, so T names can also be used if you want to write something on the board like your name to say who completed the board. So we've already completed our schematic that we can flip back to by clicking this switch schematic to schematic symbol. So we can see our schematic there, and so we see our 2 resistors, 1K and 10K, and our pinouts. So we close that, we go back here, up. So see this error that popped up? F/B annotation has been severed. So this means forward, backward annotation has been severed. This is very bad if you get this error. So if you do not change anything because the schematic and the layout need to be consistent. So if I go ahead and click back to schematic, it'll correct that for me because now it knows that it's comparing the schematic and the layout to each other. So first things first, we don't have this many components, so we're going to go ahead and use the move tool, and I'm actually going to move the dimensions in here. You can see on the top left up here, it gives you the grid size. You can adjust that if you want. I'll leave that for now, and I'm going to make this board 1/2 inch by 1/2 inch. So I'll place it there, slide this in, feel free to zoom in, put it there, and place that, whoops, place that there, oh, place that there. So you can put your cursor here and hover, and you see it's a 1/2 inch by 1/2 inch. So that looks right. And I'm going to start moving my components in. So I will take this, those pinouts, put them there. Take this resistor and put it here. And take R1 and put it here. So notice these air wires are all at different angles. So what I want to do is make it as easy as possible for it to be connected. So I know there's ground, so if I right mouse click on this guy, that's my 3.3 volts. You can see down the bottom left. If I right mouse click on this one, that's my ground. And that's on the bottom left here. It'll show you that. So I know I'm going to use my second layer for ground. So I'm going to go ahead and draw a polygon tool on the bottom layer, and I am just going to go around the outline of the board. So it's created this outline for me, and now I'm going to go to the name tool. So this is critical that you name this ground, because now I'm going to do this polygon ground, and now it's going to know that all those things should be connected. So I'm going to click OK, and remember the ground wire was right here, also here. Oh, whoops, not there. Also, I guess that's it, just right there. So when I click rat's nest, it is going to calculate the shortest air wires, and it's also going to fill in my ground plane, so watch. So boom, it fills in my ground plane, and now it knows that my pin that I have going through the board, it should be connected to ground here. So it's all connected. And now the second layer is ground, and the top layer is not connected except for at this pin. So I'm going to take these resistors and I'm going to try to reorganize them. So I'm going to right mouse click to rotate after I select it on move. And I'm going to know it should be right next to this V out, like that. And this guy, the air wires look best something like this. So maybe I'll shift this guy up a bit. Okay. And again, this is not a great layout, but I'm doing this for just to show you what it's like. So notice this is ground, and so it tells me to connect between these two, but that's probably not the best way to go because I know the ground is directly underneath here. So I'm going to select the route trace tool, go to the top layer. I'm going to click here, and so now you can see the angles that it's creating. So it's trying to do a right angle because of these top things. I'll use a 16 mil line. I'm going to want a circular via, and I'm going to choose my drill to also be 16 mil. And normally I leave diameter on auto. This has to do with the ratio of the amount of pad on the via versus the drill hole size. And I'm going to switch this to 45-degree angles are ideal for most circuit board layout. So this looks like a little too coarse of a grid. So if I go up here and click grid, turn it on, it's very coarse for what I'm looking for. So I'm going to actually have this. So now I get a little more resolution on this thing, and I can click the route here, and then I'm going to switch it to the bottom layer, which now it's going to use this via that I had selected, or the via tool down here. I don't have to use the via tool, and just double click on the second layer. So what it did is it now added a trace down here, and it used a via to get down there. And if I click rat's nest, that yellow wire that was just there disappeared because it knows it's connected. So I'm going to go ahead and connect the other guys that I need to up here with the route trace tool. It's a nice 45-degree angle there. And then I need to connect this So again, it's not the best layout in the world, but I'm showing you. Now notice all this text is kind of, so all the electrical stuff's good. My rat's nest is clear. And so I want to check I want to be able to clean up some of this. So I'm going to use the smash tool. So the smash tool will allow me to actually move the text around for that component that I smashed. So I'm going to move R1 here, and I'm actually going to delete the 1K because I can relate R1 back to 1K on the schematic as I just pulled up there and showed you. I'm also going to smash this guy for consistency and delete the 10K, and I'm going to reposition the R2 in a better spot, like right there. Also, the JP1 is kind of overlapped, but I only have one connector, so I don't really think it's important. So I'm going to smash it, and I'm going to move this out here, and then I'm going to right mouse click delete. And so now the board looks a lot cleaner. Hit rat's nest, everything's still good to go. I'm also going to do text, and I'm going to label this demo 1. Click OK, and you can see that now it's red, so that means it's on top layer. So I'm actually going to want to move that to T names, because T names is where I've been putting all my my writing, and it's going to be the silk screen. I'm going to reduce the size here to 4. Place demo 1 there. So now we have a decent looking board here, a nice board outline, the ground plane underneath, the via. We can go ahead and click ERC to check for any errors. It says part JP1 has no values. That's fine. We're not worried about that. And then if we run DRC, it will check things. So you can input different things from your fab house. So in this case, we're using 8 mil separation between things. I'll make another video about the details of this. I don't want to go into too many details if you're just trying to make an easy board. So I recommend using like 8 mil is a good rule of thumb for most companies. Masks is they have different rules for masks at different companies, same kind of thing. Thermals are interesting, so let's talk about that real quick. If I right mouse click on here, it has, this one doesn't, whoops. So what thermals are actually these little lines that come in to connect the ground plane. So if you do not have thermals connected, this will all be blue copper underneath, which makes it hard to solder. So thermals are a good option most of the time. So normally it's right in here. I'm not sure why it's not showing up. Yeah, so I don't know. We can discuss that in a different video. But you can see the thermal here is this like T that's creating with the copper. So thermals are recommended for soldering unless you're doing high frequency RF or high speed digital stuff. So now if I run the DRC, it'll run that 8 mil check. So I'm going to do select. Oh, whoops, wrong button. I'm going to do check. So it'll run through, and so it has a problem with clearance, so my V is a little too close, and the drill size is not right. I know the drill size is going to be fine, but I'm just going to shift this via a little farther away, just so it's happy. That via probably would have been fine with most companies, but I'll just show you how you can correct that error. Now you run check. So now there's an error with dimension because I'm too close to the border. So we can shift this border out. So I'm going to shift out the ground plane. Go ahead and move this. Shift that guy out. Shift that guy out. Rerun the rat's nest. And rerun DRC. Check. So now we've got rid of all those errors except for drill size, which I know is fine. And this is pretty much your completed board. So next time I'll show you how to generate your Gerbers to actually send this board out to a company, and then we can start with more complicated boards. Thank you.